The amount of bacterial growth in a petri dish follows a logarithmic function. The recorded data are as follows. Time in hours, 1, 2, 3. Bacteria, 25, 29.6, and 51.8. Use logarithmic regression to find a logarithmic equation that models the bacterial growth. Using your model, predict the amount of bacteria in the petri dish after 11 hours, and then determine how long it'll take for the bacteria to reach 300 milligrams, I guess, in the petri dish. So, all right, we're going to use LnReg, right? And then we're going to save that into our calculator so we can do B and C. Let's run off to our calculator right now and do just that. All right. In order to do LnReg, you're going to hit Stat first. And then edit, put your X values in L1, so 1, 2, and 3. And then you're going to put your bacteria in L2. So that was 25.1, 39.6, and 51.8. Now, we're going to go to Stat, we're going to go to Calc, and LnReg, don't be confused with LnReg, is number 9. Okay, number 9. Now, not only do we want our formula, we want to store it in our calculator as well. So we're going to go down to Store Reg EQ. We're going to hit vars. We're going to go right to y vars, hit enter for function, and then enter for y sub 1. And then what this will do is save our function in y sub 1 for y equals. So let's hit enter. Let's go to calculate. And there's our terrible looking equation right there. So when we go over, we're going to write out y equals 24.536, because we're going to round it, plus 23.939 ln of x. So let's go over and do that. All right, so it definitely wasn't pretty. Let's see if I gave myself enough space. I'll just write it up here. Y equals 24.536 plus 23.939 ln of x. Yuck, yuck, yuck. All right, using your model, predict the amount of bacterial in the petri dish after 11 hours. So basically plug 11 into U. Let's go and see what happens when we do that. Now, part B asked us to use this model to predict the amount of bacteria after 11 hours. All right, so if I were to go over here to y equals, there she is waiting for me. If I hit graph, we don't see it well, but there's a logarithmic function. Here's an issue. We want to see what happens after 11 hours. So the easiest way to do this is by going to second graph, scroll all the way down to 11, and at 11 you get 81.939. Okay, 81.939. Now the other way of doing this, right, is if you were to go to second trace and try to type in our value, it's not going to work when you plug in 11. See? And it's because our window doesn't go out to 11. So if, let's just say I asked you the same question but asked you for 111 hours, the last thing you're going to want to do is go to my table and scroll all the way down. So a way that you can fix this is you can go to window. I guess I have to quit out of this first. You go to our window and you change the X max so I can get the number that I want, so I'll change it to 12. And now we get second, trace, value, type in 11, and yeah, we get the same exact number that we got before. But that's how you would do it. And we got 81.939 milligrams, or as Lil Wayne says, milligrams. It's a song, kind of. Now, determine how long it would take for the bacteria to reach 300 milligrams in the petri dish. This is going to be ugly. Let's see what we get. Now, part C asks us to see how long it'll take us to reach 300 milligrams. So what I need to do is I need to go to y equals and make 300 one of our y equals options, because we're setting this guy equal to 300. Now, when I hit graph, right now I'm not going to see anything because if I have y equals 300, my window only goes up to 10. That's not near enough. So let's change it to 350 and see if our lines intersect. If you remember, I had 12 out here from before. Let's see if 12 will do it. When I hit window, graph, not even close. So this is going to take a really, really, really long time. So if I'm using this, which I already started, why don't I make my X max, I don't know, 100 and see if they cross. I have a feeling it won't. Yeah, not even close. And again, that's because logarithmic functions, they increase at a decreasing rate. So this guy's going to take forever. So 100 didn't do it. Let's try 1,000. Let's try 1,000. Nope. So let's try 10,000. Nope. So let's try 100,000. There we are. I'm even paranoid. Boy, does that make me paranoid. I'm still not sure. So let's try 200,000. 0, 0, 0, 0, 0. There we go. Now they definitely cross. So I'm going to hit second, trace, and find out where these guys intersect by hitting 5. I'm going to go just to the left of where they intersect, here, hit enter. I'm going to go just to the right of where they intersect, so that should do it. Hit enter. And for guess, hit enter. And it looks like that happens at 99,403.786 hours. Gross. Let's go back and write it out. Well, it was ugly, and we ended up with a kind of a long time, 99,000 hours, 403.786 hours. Terrible. So yeah, a little while, I guess.